So when finding the angles of a polygon, first we have to find which angles we want. Because in polygons, for example, if I had square, we have two types of angles. We have the interior angles, which mean the angles that are inside the shape, and the exterior angles, which are the angles that are outside the shape. Uh, so exterior angles will always on any pentagon, any polygon, will always equal to 360. So x will always equal 360. And the interior angles of any shape will always equal to n minus 2 times 180. In this equation, n represents the amount of sides that the shape has. What this means is, if a shape has four sides, for example, and like in this case, a square, we will fill in uh, 4 instead of n, which would make 4 minus 2 times 180. This means 2 times 180 equals to 360. This means that the sum of the interior angles in this shape is equal to 360. And this works on every other shape, every polygon. So for example, if I had a pentagon, for example, or a hexagon, or any other shape. So here we have a hexagon. Now, it might not be perfect, but still, a hexagon has 6 sides. This means 6 minus 2 equals 4. And then 4 times 180 is equal to 720. This means that the sum of the interior angles of this hexagon is 720, and the exterior angles will always equal to 360. Now, how do we make use of this in real life? Say, for example, if we were in a park and the park had a fountain, for example, and the fountain is an octagon. So assume uh, that the park had a fountain that was an octagon. We know that the sum of the exterior angles of the octagon are equal to 360. This would mean that each exterior angle would be equal to 360 divided by the number of sides, which is 8, which would equal to 45. That would mean that when turning any corner, you'd be turning at a 45-degree angle. If I was walking here and turned here, I would turn 45 degrees. This is one use of angles in real life, as the shape of the fountain can decide how much the person turns. So another example would be if that same park had seating areas that are pentagon shaped. We would know that the interior angles of this shape would equal to, so first we must find what is the sum of the interior angles of the shape. Using the rule that we just learned, we will do 5 minus 2 equal to 3, and then 3 times 100 times 180 is equal to 3 times 180, I mean, would be equal to 540. This would mean the sum of the interior angles of the shape is 540. And since there are 5 angles in the shape, we to find how much each angle is equal to, we must divide 540 by 5 equal to uh, so now we know that each of these angles equal to 108. That would mean when walking in the seating area, when turning any corner, you should turn 108 degrees. These are a couple of real life uses of angles and polygons, and knowing learning the angles of polygons and how to calculate them and find them. Now, this video explains how to calculate the angles and how to find them at the interior and exterior angle. So we learned the rule n minus 2 times 180. This is how much interior angle and exterior angle of polygons are always equal to 360. Now, something that many people face challenges with and have mistakes with is people always forget to uh, subtract 2 from n. So, for example, if I had a square, instead of doing 4 minus 2 times 180, they would directly go and say 4 times 180, which is completely incorrect and will not give you the sum. And finally, creativity always helps in mathematics as it helps visualizing things and how things are used. So, for example, here we use a real life example with the park and the seating areas, which helped us understand how this rule is used in real life and how it's used in architecture and when making things and designing things like en- engineering and civil engineering. So these rules are always used in real life and in jobs around us every single day. And it's always useful to be creative and expand on the ways of learning uh, these rules, especially in polygons.